Hello students, so today we will start the unit 6 of chapter 1. Okay, so today we will learn about the measurement of mass. Okay, so before going to the measurement of mass, first we need to know what is mass actually. Okay, so if you see the definition of mass, what is mass? Mass is the amount of matter. Okay, what is mass? We know that everything in the universe is made up of matter. And what is the mass of that substance or mass of that body? It is the amount of matter contained in a body. Okay, that is our the mass. Okay, so you can write the definition from here. The mass is the amount of matter contained in a body. Okay, so how we measure? Mass is measured by generally physical balance. When we go to market to buy something, okay, or a beam balance. Okay, so we need not to know how to balance this. Okay, physical balance, construction, we need not to know. Just you need to remember that mass is measured by generally physical balance. Okay, or beam balance. The photo is here. So this is the physical balance. Okay, something will be here, pan will be there, so we can balance it. Okay, so you can just read the how to use the physical balance. The construction and the working is given. Okay, so just remember the definition of mass. Okay, and the instrument by which we can measure it. Okay, as these are all practical substances. Fine. So but we need to know the measurement of time. Okay, measurement of time. So for this, what is time? Time is this is the definition of time. What is time? It is the interval between two events. Okay, so it is the what is measurement of what is time? It is the interval between two events, and that interval between two events is known as time. And simple pendulum is a device for measuring time. Okay, so simple pendulum, it is a device which is used to measure the time. So now we need to know what is a simple pendulum. Okay, so mainly we can see a pendulum in a clock tower or in our house also. Okay, the clock. So simple pendulum. So what is simple pendulum? It is a heavy particle suspended by a weightlessness and inextensible string and oscillating freely without friction about a point to which the upper end of the string is fixed and constitute a simple pendulum. So that means your suppose this is your the surface at which the string is attached. Okay, so this O is the point of suspension and this will be the L. This is the length of the string, or we can say the effective length, and at the end of the string we have a bob attach it. Okay, and this will be the your mean position, and the bob rotates about the mean position, not or rotates, it oscillates about the mean position. That means from A to B it will go, and after B it will come to again A, for again from A it will go to C, like this. So it will oscillate about its mean position A. Okay, so if you see the construction, let OA, okay, so you just see the figure, let OA is this part, OA. Okay, so OA be the mean or the rest position. Mean position means the rest position of the pendulum, and when the bob of the pendulum is pulled aside from A to the position and then released. Suppose A is displaced from A to B and then released it. So after releasing it, it begins to oscillate. So that means it goes from A, and then from A it goes to C or B. So suppose it goes to C, then the points B and C are equidistant from A. So that means the bob was initially at the mean position A, we stretch it from B and again we release it. So it will again move from B to A, then again from A to C, again from C to A, and again from A to B. So that means the points, these 2 points, that is the points C and B, these are equidistant from A. So these are at equal distance from the mean position A. However, in actual practice, the pendulum cannot made to oscillate in an absolutely freely way. Thus, after some time, it gradually comes to rest on account of the friction. So due to some friction, it gradually comes at rest. Okay. Okay. So regarding the simple pendulum, we need to know some definitions. Okay. So the first definition is your oscillation. So what is oscillation? Oscillation is the complete to and fro motion. To and fro motion means, so like this, again it will go from here, again and again it will go from here, like this. This is our to and fro motion, like this. Okay, so the complete to and fro motion of a pendulum constitute one complete oscillation. That means, suppose it was at A, it was stretched at B. Now again it will come to A, and again from A it will go to form C, and after C it will again come at A. So that means starting at A and again making one complete rotation and again come back to A constitute our one oscillation. Okay, and what is time period? To make complete one oscillation, that it is the time required, or it is the time taken by the pendulum to take one complete oscillation, that is known as our time period. Okay, amplitude, next is our before going to the frequency of oscillation. So what is frequency of oscillation? It is the number of oscillation made by pendulum in 1 second. So in 1 second, how many oscillation have been made? So that is known as our frequency. And similarly, amplitude, it is the maximum displacement of the pendulum from its mean position. So that means the distance from A to C or from A to B is known as our amplitude. So this is the maximum displacement a pendulum made from its mean position. And effective length, what is effective length? So bob is generally attached from a particular fixed surface. So this length is known as our effective length. It is the length between points of suspension and the center of gravity of the bob of a pendulum is known as our effective length. So you need to remember all the 5 definition. Okay, so now we will move to the factors on which the time period depends. T, time period, the second point. At what factor the time period depends. Okay, so generally it depends upon the length, okay, the center of gravity, and if we just compute it, so you need to remember that the time period of a simple pendulum is given by this formula. So just you can remember this formula, that is time period of a simple pendulum is given by T equals to 2 pi root over L by G, where L is the length of the string, or this is the effective length, and G is the acceleration due to gravity. Just you need to remember this formula, that will be enough. Okay, next okay, so the graph portion may not be required, you can skip this. Okay, so in the above this topic, so you remember all these 5 definition: oscillation, time period, frequency of oscillation, amplitude and effective length, and after that the factors on which the time period depends, that is the length of the pendulum and acceleration due to gravity, L and G. Okay, so combining them we will get one formula, that is T equals to 2 pi root over L by G. That will be enough. Okay, so we have another one definition, small definition is there. So that is our second pendulum. So a pendulum in which the time period of 2 seconds. Okay, so generally where the time period is our 2 seconds, that type of pendulum is known as our seconds pendulum. Fine. So formula will be same, T equal to 2 pi root over L by G, and all will be same. Okay, so no need to look for the graph. Next we can, I think all of you know how to plot the graphs. Okay, so again, so let us explain this. What is graph? Generally what is graph? A pictorial representation of 2 physical variables. Okay, there will be 2 variable x and y, or any, no need to take x and y, you take any 2 variables. Okay, so we just express or we represent that 2 values in a graph, or it is the picture. Okay, so a pictorial representation of 2 physical variables recorded by an experiment is known as our graph. So how we plot the graph? Okay, so suppose there are 2 variables, that is our current and potential difference. So if we calculate, suppose when the current was 0.20 ampere, the potential difference was 0.24 volt. Likewise we have 1, 2, 3, 4, 5 values of current and 5 values of potential differences. Okay, now we need to plot it. So how we will plot it? So this first we can so to convert, as all are in decimals, So if there is problem to plot it, so for easy calculation we generally convert or we rationalize as under. Okay, so 0.20, so 0.20 can be written as, we have already learned about that, any number between 1 to 10 into powers of 10. So we have to put this decimal, or we can take this to be 20. So decimal have been put or it have moved 1 2 places. So that means we have to write into 10 to the power minus 2 as it has moved towards the right. Similarly 0.45, this can be written as 45 into 10 to the power minus 2. So 0.95, this can be also written as 95 into 10 to the power minus 2, like this. So all the bases are same, 10 to the power minus 2, 10 to the power minus 2, 10 to the power minus 2. So now we have got the numerical value, that is 20, 45, 95. So it will be easy to plot in the graph. Okay, so now how we will plot it into the graph, we will learn here. So okay, so the graph paper will be will look like this. Okay, so there are two axes. Okay, so there are two variables. Which are the variables? Generally we have current, that is our I, and potential difference, that is represented by V. Okay, so how we will plot it? So we will make x-axis and y-axis, we need to take suitable scale. Suitable scale means the difference will be same, so that means the gap between the two values must be same. Okay, so suppose the value of the current was, if we see clearly the value of current, which was the value, it is like your 20, 45, 87, 20, 45, 87, like this. Okay, so suppose this point is 0, this point is 20, this point is 47, this point is 87, like this we have to plot it. So but we cannot plot this. Okay, why? Because the distance between 20 and 45 is not same, or 45 to 87 is not same. So how we have to plot? Either we can take the scale, because these boxes, you can see from here to here there are 5 boxes, it is also 5 boxes. So either we can take 5 box equal to 10 units or 20 units. So 5 box equal to 20, this will be 40, this will be 60, this will be 80, like this we have to take the value. And again in y-axis, what we will do, in the x-axis we can plot your the current, and in the y-axis we can plot the potential difference. So again we have to take the axis. Okay, 10 boxes or 5 boxes equal to how much unit, so we can take that. So here you can see in the graph, so the origin was there, so we have started from 20, so 10 boxes equal to 20 units. So you can see the gap, 20 to 40, 40 to 60, 40, 60 to 80, 80 to 100, like this. Okay, and again in vertical, the you can see that 10 boxes is again taken as 20 units. So 10 boxes equal to 20 units, that is 20 to 40, 20 units, again 40 to 60, it is 20 unit, difference is 20. So now we have to plot it. So that means the first point was when x was 20 or the current was 20, the value was 0.24. So we need to find which one will be 24. So this point will be your 20, 24. Similarly for 45, the value was 64. So this will be here somewhere, will be your 45, like this. Okay, and we have 54. So 50 will be, this will be 50, 51, 52, 53, 4. This will be. So in this way we plot it, and we will get a straight line. We may get a straight line or we may not get a straight line. Okay, so it is very easy. So you just go through this. Okay, all the points, characteristic of a straight line graph. Okay, so a straight line graph shows that the two variable quantities are directly proportional to one another. So that means if we plot, and if you are getting a straight line, okay, after plotting, that means we have two variable in the x-axis and the variable in the y-axis. So if you get a straight line, that means that the two variables are directly proportional to one another. That means if one increases, the other one will be also increase, and if one decreases, then other one will be also decreases. Okay, fine. So you just go through this. Okay, so the graph may be your may not be straight line. So you can see that the graph between your volume and pressure is not a straight line. Okay, it is a smooth curve. This type of curve is known as a smooth curve. That means it has been found that if a graph is plotted between pressure and of an enclosed gate at a constant temperature against its volume, the graph line is smooth curve. That is, we do not meet at x-axis or y-axis. Okay, generally they do not intersect at x-axis or y-axis. So just go through this type of graphs, different graphs. Okay, so basically remember what is graph and how to plot the points in a graph. Okay, that will be sufficient. Okay, and in the previous slides just go through the definition of what we have learned. Simple pendulum, the factors affecting the time period, some definitions regarding simple pendulum, then what is time, then the construction of simple pendulum, and what is mass. Okay, so you just go through all this, then it will be sufficient. Okay, so this constitutes our first chapter. So after this you practice all the question, and I will try to send you all the question and answers. Okay, and after that if you again find any problem, then you can contact me. Okay, thank you.